Here's a lesson on the distributive property. In this lesson, I'm going to teach you how to expand and simplify a lot of different types of products, starting with monomials multiplied by binomials, and then moving forward to multiplying by polynomials that have more than two terms, and then even polynomials that have nested brackets like we see here, and then finishing off by multiplying binomials by binomials here. So let's go back to the start and learn the basic distributive property. The distributive property states that multiplying a monomial by a sum or difference of terms is the same as multiplying the monomial by each term inside the parentheses and then adding or subtracting the results. So if we zoom in on this rule here we have a monomial, a, multiplied by a binomial, x plus y. To expand and simplify that product, this a has to be multiplied by both terms of the binomial. So we would have to do a times x to give me ax, and then I would have to add the product of a times y, which is ay. And notice when doing this distributive property, so when expanding the product, that gets rid of the brackets. So our resulting expression just looks like this, a times x plus a times y. And let me give you a geometric representation of why a times x plus y is equivalent to a times x plus a times y. What we have here is this large rectangle. Notice the area of that rectangle would be its length, a, times its width, which is x plus y. So the area of this whole shape would be a times x plus y, its length times its width. But we could also consider its area by adding up the area of these two rectangles that make up the bigger rectangle. So if I just focus on the rectangle on the left, the area of that rectangle, well, the length and width of that rectangle are a and x. So its area would just be a times x. And the rectangle on the right, the dimensions of that rectangle, well, its length is a and its width is y. So the area of that rectangle would be a times y. So the sum of the areas of the red rectangle and the blue rectangle would be equal to the total area of the big rectangle, which is why if we look at this statement down here, a times x plus y, which would give us the area of the big rectangle, which is a by x plus y, is equal to a times x plus a times y, because it's equal to the area of the red rectangle plus the area of the blue rectangle. So hopefully that helps you understand that when we have a times x plus y, what we do is just multiply a times x to get ax, and then add the product of a times y. And let's go ahead and use that distributive property to expand and simplify the following expressions. And when it says expand, well, expanding an expression means to use distributive property to get rid of the brackets. So if we look at part A, if I want to expand this, I want to get rid of the brackets by multiplying this 5 by both terms inside this binomial. The 5 has to be multiplied by the x, plus the 5 has to be multiplied by the 4. And now I need to simplify my final expression. All that I can simplify is 5 times 4, which is 20. So 5 times x plus 4 is equal to 5x plus 20. And if you wanted to, you could pick a test value for x to make sure that this statement down here is in fact equivalent to the original expression. Any value for x subbed in for that x or that x should make these expressions equal the exact same value since we're stating they're equal to each other. For example, if I tested an x value of 2, in the original expression, it would be 5 times 2 plus 4, which is 5 times 6, which is 30. But if I sub it into the bottom expression, I would have 5 times 2 plus 20, which is 10 plus 20, which again is 30. Notice because this expression is equal to the original one, they're going to result in the exact same value. If they didn't, we would know we did something wrong. Now let's go ahead and move on to part B, where once again, I have a monomial times a binomial. So this negative 2 has to be multiplied by both of the terms in the binomial. I'll have to do negative 2 times 7x, and then I keep the operation, so minus, and then I do the negative 2 times the 4. And now simplifying this expression, I can simplify both of these products. Well, the constant factors of negative 2 and 7 can be multiplied together to give me negative 14, so it becomes negative 14x minus I have negative 2 times 4, which is negative 8. And when subtracting a negative, I can rewrite that as addition. So it would be negative 14x plus 8. And now let's move on to part C, where this time I have a monomial multiplied by a polynomial with 3 terms, which we call a trinomial. So this negative 3 has to be multiplied by all 3 terms inside that trinomial to expand it. So I'll do negative 3 times 2x squared. Then I'll keep the operation, so minus. Then negative 3 times 5x. Keep the operation of plus. And then negative 3 times 4. And now all 3 of the terms I have here can be simplified. Negative 3 times 2x squared, multiplying the constant factors together, it gives me negative 6x squared. Minus negative 3 times 5x is negative 15x. Plus negative 3 times 4 is negative 12. And then subtracting a negative can change to plus, and adding a negative can change to minus. And this is my final answer. There's nothing else I can simplify. These 3 terms are not like terms, so they can't be collected together. Moving on to part D. Well, to expand means to get rid of the brackets by finding the product of the monomial with the binomial using distributive property. And I'll have to do that with this product as well to get rid of all the brackets, and then I'll collect all my like terms at the end to simplify the expression. Focusing on the first product, this 2 has to be multiplied by both terms inside that binomial. The 2 has to be multiplied by the 6m, keep the minus operation, and then the 2 has to be multiplied by 3. Plus, now looking at this product, this 3 has to be multiplied by both terms in the binomial. The 3 has to be multiplied by 16, plus the 3 has to be multiplied by 4m. And now I'll simplify all 4 of the terms. 2 times 6m is 12m, minus 6, plus 3 times 16 is 48, plus 3 times 4m is 12m. And now collecting my like terms, I notice I have a 12m plus a 12m. These terms are like terms because they have the exact same variables with the same exponents. They both have an m to the power of 1, so they're like terms. I can collect them together by adding their coefficients. 12 plus 12 is 24, and then keeping the variable part the exact same. So 12m plus 12m is 24m. And then any constants are like terms as well. Negative 6 plus 48 is positive 42. So there's my final answer, 24m plus 42. And now let's move on to the next section, where the monomials in front of the binomials are going to involve a variable. So when distributing a monomial that involves a variable, we have to remember the product of powers law. And here's the product of powers law. When multiplying 2 powers that have the exact same base, right, their bases are both a, we can simplify the product into a single power by keeping the same base of a, but then adding their exponents, m plus n. So if we go to our first product here, example 2a, which says to expand and simplify again, our monomial this time is a variable. So when I expand this, that means to simplify the product by multiplying the x by both terms inside the binomial to get rid of the brackets. So the x has to be multiplied by the x minus the x has to be multiplied by 3. And when simplifying this product of x times x, you can imagine that both of those x's have exponents of 1. So when multiplying those powers together, I keep the base of x and add their exponents. 1 plus 1 is 2, which is why x times x is x squared. Minus the product of x and 3. Usually we write the constant factor first, so I write it as 3x. And then on to part B. This time I have a negative x that has to be multiplied by 7x. Then I keep this operation of minus and do the negative x times 4. Simplifying both the products, negative x times 7x. Well, let's do the constant factors first. This is like a negative 1 times 7, which is negative 7. And the x times x, I keep the x and add the exponents of 1 plus 1 to get 2. So the first product is negative 7x squared. And then the second product, negative x times 4, is negative 4x. So I would have to subtract negative 4x. And subtracting a negative, I can rewrite that as addition. Negative 7x squared plus 4x. Moving on to part C. This time I have a monomial that involves a variable multiplied by a trinomial. So to expand and simplify this, I need to multiply this negative 3x by all three terms inside the trinomial. I have to start by doing negative 3x times 2x squared minus negative 3x times 5x plus negative 3x times 4. And then for all three terms, I can simplify their products. Negative 3x times 2x squared, multiplying the constant factors of negative 3 and 2 gives me negative 6. And then multiplying the variable factors, x times x squared, because they have the same base, I keep that base of x, and add their exponents of 1 and 2, making it x to the power of 3. Minus negative 3x times 5x will be negative 15x squared, plus negative 3x times 4 is negative 12x. And then just simplify subtracting a negative to addition and adding a negative to subtraction. And because the exponents on the variable parts of these terms are all different, these are not like terms, so I can't simplify this any further. And before we move on to the next example, I want to point out how we can start thinking about these products. When I multiply the negative 3x by this entire trinomial, I can think of finding three products. The negative 3x times 2x squared, which is negative 6x cubed. And then the next product, the negative 3x, gets multiplied by, we can think of this as a negative 5x. Instead of thinking of this as a subtraction operator between these two terms, we could think of this as a negative 5x term that's being multiplied by negative 3x. A negative times a negative gives me this positive 15x squared. And then the negative 3x being multiplied by the positive 4 gives me negative 12x. So that can help you see the relationship between the original expression and our final answer. And that may help you save yourself some time from having to write out all of those products. So let's move now on to part D. I have a product of a monomial times a binomial. So this 3m has to multiply by both terms inside the binomial. I have 3m times m, then minus 3m times 5. Then I have to subtract this binomial. We learned how to subtract polynomials in a previous lesson, but what we have to do is just subtract both of the terms that are inside the brackets. So I have to subtract the 2m squared, and I also have to subtract the negative m. And if I simplify this, I get 3m squared minus 15m minus 2m squared plus m. And then we probably could have jumped to this line of our final answer without needing the line above, because notice 3m times m is our 3m squared. 3m times negative 5 is negative 15m. And then this minus sign, we could think of that as a negative 1 that's being distributed inside the second set of brackets. Negative 1 times 2m squared is negative 2m squared. And negative 1 times negative m is positive m. And we could simplify this further by collecting our like terms. I have a 3m squared and a negative 2m squared. Those have the same variables with the same exponents, so I can collect them together by subtracting their coefficients. 3 minus 2 is 1, and keep the variable part the same, m squared. And then I also have this negative 15m and the positive 1m. Negative 15m plus 1m is negative 14m. So there's my final answer, but I don't need to write this coefficient of 1. And now moving on to part E. To expand and simplify this expression, I'll have to expand both of these products and then subtract them. So looking at the first product, this half has to be multiplied by the 2w minus the half has to be multiplied by 6. And then I have to subtract the product of 2/3 and 9w minus 6. So that product will have to go in its own set of brackets. The 2/3 times the 9w minus the 2/3 times the 6. And now I can simplify. In each of these terms, I can simplify the products. A half times 2w is w, minus a half of 6 is 3, minus, I have a 9 divided by 3, which is 3, giving me 2 times 3w, which is 6w, and I have a 6 divided by 3, which is 2, so I have to subtract 2 times 2, which is 4. And now I have to subtract that whole product, meaning I have to subtract the 6w and the negative 4. giving me w minus 3 minus 6w minus negative 4, which is w minus 3 minus 6w plus 4. And before I collect my like terms, notice we could have gotten to this line of our simplification right away by doing a half times 2w to give me w, and then a half of negative 6 is negative 3, and then negative 2/3 times 9w is negative 6w, and negative 2/3 times negative 6 is positive 4. And then collecting my like terms, I have a w minus 6w, which is negative 5w, and a negative 3 plus 4, which is positive 1. And that's my final simplified answer. Now let's move on to part 3, where we look at nested brackets. So if we have brackets inside of a bracket, it's best to simplify the innermost brackets first and then work our way out. So for example, if I look at 3a, where we have to expand and simplify this, because I have brackets inside of brackets, I'm going to start by expanding the innermost product to get rid of the innermost set of brackets by multiplying the 5 to both terms inside that binomial. So I'll leave the 3 and the 2 plus, I need to do 5 times 2k, which is 10k, and 5 times negative 1, which is negative 5. So because I only have one set of brackets left, those square brackets could be round brackets. And then before distributing this 3 to all three terms in that trinomial, I could collect this 2 minus 5 inside of that trinomial. So I'll leave the 10k, and the 2 minus 5 is negative 3. And now I'll multiply this 3 by both terms inside the binomial. The 3 times 10k is 30k, and the 3 times the negative 3 is negative 9, giving me a final simplified answer of 30k minus 9. And now how about part B? There's a lot going on in this expression, but I'm going to start with the innermost set of brackets for both of the terms. So I'll leave the negative 2 and the 3x, and then I have to subtract the 4, and then also subtract the negative 2y, which makes it plus 2y, plus 5 times y, and then I have to multiply this negative 2 by the x to give me negative 2x, and the negative 2 times positive 1 to give me negative 2. And now I can simplify these products by multiplying the monomials, negative 2 and 5, by all of the terms in their corresponding trinomials. So I'll have to do negative 2 times 3x, which is negative 6x, and then negative 2 times negative 4, which is positive 8. Negative 2 times 2y is negative 4y, and then 5 times y is 5y. 5 times negative 2x is negative 10x, and 5 times negative 2 is negative 10. And then looking for my like terms, I have a negative 6 and a negative 10x. That's negative 16x. I have a negative 4y and a positive 5y. That's a positive 1y. And then I have an 8 minus 10, which is negative 2. So there's my final simplified expression. Notice there's no brackets left because when we expand, when we multiply a term in front of the brackets by all the terms inside the brackets, that gets rid of all the brackets. And then the last thing I want to show you in this lesson is what if we are multiplying binomials together? When multiplying binomials, we have to multiply every term in the first binomial by every term in the second binomial. And the acronym FOIL can be used to remember all four products that you have to calculate. FOIL stands for first, outside, inside, last. And after multiplying, always make sure to collect your like terms. So if we look here, this is how it works. If I have this binomial times this binomial, both terms in the first binomial have to be multiplied by both terms in the second binomial. And to remember to find all four of the products, you can multiply the first terms together, x times x, which is x squared. Then you can multiply the outside terms together, x times 3 is 3x. Then the inside terms, 2 times x is 2x. And then the last terms, 2 times 3 is 6. So FOIL, that acronym, first, outside, inside, last, will make sure you find all the products. And then, of course, collect any like terms. 3x plus 2x is 5x. So let me go ahead and show you how this works for these two examples, starting with A. I have a binomial times a binomial. So each of the terms in the first binomial have to be multiplied by each of the terms in the second. I start by finding the product of the first terms, x times x. And then between the products, you can always put plus the product of the outside terms, x and negative 5, plus the product of the inside terms, 4 and x, plus the product of the last terms, 4 and negative 5. And then simplifying all these products, I have x squared minus 5x plus 4x minus 20. Right? The first term's x times x is x squared. Then x times negative 5 is negative 5x. Then 4 times x is 4x. And then 4 times negative 5 is negative 20. And then the middle two terms are like terms, so I can collect them together. Negative 5x plus 4x is negative 1x. So there's my final answer. And moving on to part B, let's see if we can save ourselves a step here just by finding the products right away. The product of the first terms, 3x and 2x, is 6x squared. And then 3x times 7 is positive 21x. And then the inside terms, 1 times 2x is positive 2x. And then the last terms, 1 times 7 is positive 7. And again, the middle two terms are like terms, so I can collect them together to make 23x. And there's my final answer. So hopefully by the end of this lesson, you feel comfortable expanding and simplifying expressions using the distributive property when we're multiplying a polynomial by a monomial, and also using the method of FOIL to multiply binomials together. Make sure you go to jensenmath.ca to get the worksheet of practice questions to practice doing these multiplications.
Jensen